Yes.
Tilman. So we have a guest.
Who do we have today?
It's Florian Michahelles, I think, from California, I guess. So Florian, what are you doing there?
Yeah, I actually moved here 7 years ago from Switzerland to beautiful California, and I had the pleasure back then to build up a new research location for Siemens. And so we established a group first around the topics on web technologies and semantics, and now we more and more moved into the field of digital companions. So building a bridge between AI and human user interfaces. How can we make AI useful for users related to the business fields of Siemens?
So far in this conversation, we talked about a full range of different topics. We talked about VR, mobile HCI, conversational agents. You might relate to that, wearable computing, or the web. What do you think is the future? So is this one of these different topics where you say in the future we will all sit in virtual reality, or is it really mobile? Where do you see the future of interactive devices?
I think it will be probably a mix of the human sensors and to have new interfaces to provide information to the user. What we are focused more here is actually in the back end, so in providing the information. So what is the world knowledge of the machine? So how can the machine give me suggestions? What does the machine know about my activities? But what does it also know about instructions, about suggestions, about advice it actually can give? And how can we create this knowledge? How can we curate this knowledge? And finally, how can we provide this knowledge to the user to become more effective, to become more productive in what you want to do?
How important is then the actual device or the interactive system in the end? Do you think that will play a major role? I mean, at the moment, I think we see like mobile phones, they're really successful. But will the device matter in, I don't know, 10, 20, 30 years?
The device matters. What I learn here in industry is it matters a lot on the cost factor. So we, for example, build a lot of prototypes on HoloLens, which is nice to show a fancy demo at a fair or at some events. But it's far away from actually putting this to production just because of costs. So that's why then this demo at the fair more and more gets integrated into a tablet, because this is a device what people have. This is a device what you can use, and this doesn't create more costs. So ideally, that's just what we learn. It is something that's cheap, something that's already deployed, and of course something that makes sense and works. The mobile phone is probably not quite there yet, but it doesn't have to be super fancy. It's more about cost efficient, shouldn't require training, and should be deployed and should be ready to use.
I was just wondering, you talked about a lot of this back end implementations, but what are some of the more application side of things that you're working on and where interaction comes into play?
I think a very illustrative example I can talk about is actually sharing knowledge of assembly of instructions. So what we have built, for example, is how do you install an industrial system? How do you install an industrial computer? So today this knowledge is shared in paper documents, in PDF documents, and you have several hundred pages. You have to find the right one, the relevant one, and it may be very tedious to use, and frankly, people don't use it. So this information, these instructions are not very accessible. So if we want to provide this in AR, of course, that's much more intuitive, that's much more interactive, but someone has to create the content, which is very expensive. So we built a system where we parse this existing text documents and then try to generate some generic animations out of this textual description. So basically to rely on the information that we have, but make it more accessible. And this way, a user can then use it in a much more intuitive way. And an alternative to that, what we also built is where we do not rely on the paper instructions, but we observe a user. So we observe someone that does it. We extract some basic actions and also annotate that and create an animation out of that. And this way, we can establish a knowledge transfer between workers. So we can observe people, but we do not take the raw video. We try to extract meaning from the actions that we can recognize, and then can transfer that to someone else and can establish a knowledge sharing among people here.
And how much of your time do you then spend in your lab kind of prototyping these systems and researching them versus going out into some factories and deploying that? And what kind of factories have you seen from the inside?
Yeah, so factories, I've seen quite a few, which is always very exciting. So, for example, we visited our train factory here in Sacramento. We have visited the electronics factory in Germany, in Amberg, and these are two extremes, and that's why I mentioned them. So trains, as you can imagine, are very big, very bulky devices. You build like one train wagon a month, whereas electronics is like a rapidly high-speed production environment, very highly optimized. So one is more like a manual workshop where you work on single items, and the other one is mass production. And so these different environments have very different requirements and also require very different solutions. So in the electronics factory, we have much more data available. It's much more about optimization, whereas in the train factory, it's still a very human-centered tasks. And a lot of information is still shared in a very informal way, which opens a lot of opportunities to actually get the knowledge out of people's heads and actually formalize that and make it easier to transfer and also to capture this knowledge and make it available to others.
So is that the biggest difference between research or academia and industry, is that you actually go out and in the end deploy these systems? So something I would probably not really do. Do you think that is the biggest difference, or are there other differences?
That is actually when I started what I thought would be the difference, but my experience actually it's not, because it is a very long life cycle, and we in the research division are usually not the ones who deploy. So our work as an academia ends with a prototype, and then we would hand it over to someone from a more productive environment who would then also be able to write productive code, would also provide maintenance and liability 24/7 and so on, what we don't do. So no, we don't go that far. But I think the difference is what we do has to be relevant and has to have a use case or a business case. So which is very challenging, because not only do you have to develop something new, but you also have to explain to someone, what do you get out of it? How much money do you save? Or how many more units can you sell with this? Which is an unknown. It's an unknown. Does the prototype work? This is what we know from research. Here I also have to explain or have to come up with a story how much money you would make. And this is the main difference to actually do this, which then as a consequence means you are very often not jumping that far, because the closer you jump, the more reasonable it is actually to come up with this business part of that. So that's the main difference from my experience.
And what comes usually first? Is it a business case or is it the research idea?
That's a good point. That's a good question. So it can be both. It can be both. So the business case is more when our business unit perhaps has a customer or they have a problem themselves and say, this is something we got a request for, we don't have a product for, we can't do this. Can you help us? Because we heard you do AR, we heard you do this and that. And then basically the problem is defined and we can start. very often it's also the other way around, that it's a technology push, that we have this demo, that we have something which we think is cool, and then we look for a problem. And then from my experience, the solution we have for our fake problem in mind very often changes, because we are running around with a hammer, and the nail actually is not a nail, it's maybe a screw, and then also our hammer suddenly turns into a screwdriver. And so there is some convergence happening, which is usually a very exciting journey.
How do these business cases then look like? So I've been thinking about turning instructions into AR instructions. So as a consumer, I could imagine like IKEA could do that, right? So then these instructions on paper, they then come as a HoloLens. And then for IKEA, at least, like where would the advantage for IKEA be in this example?
Not so sure about IKEA, but if I try to think now about the industrial environment, so Siemens has like hundreds of different products, and there's a huge product catalog where people can order, and then there is support pages where you have all these PDF documents there, and now you can make the case: how much does it cost to create all these PDF documents? And then from your experience, how many of your users actually use them, and what kind of additional support in terms of consulting hotlines you have where people ask you questions. And then if you can quantify that, how many people do you have, how much does it cost you, how many perhaps product returns you have because people don't understand, that's something you can quantify. Now, when we say with our generation, how much does it cost us to run the computing platform, and how much less personnel perhaps we would need in order to create that? Can we do a user study and can show like the satisfaction or the speed of acquiring the knowledge? I think this is the direction where you make the business case. Of course, the ultimate number you would only see once you sell it, but here it's only important to convince someone to say, okay, I'm convinced, I'm willing to take the risk, let's try this. We have one product we start with, we have one customer to try with, and then you would incrementally roll it out. So that's how I see it here. Business case, as I understand, and I also studied computer science, not business administration, but business case always sounds like this big word. But what I learned, usually just the very elementary calculation operations like plus and minus are actually sufficient to do a business case. It's really something that should be positive in the end, not to forget multiplication, to have some scaling in here. But it's not that magic. It's more about making the argument, where do you get the parameters from? But the actual calculation can be very short and very simple.
It seems to me, with Siemens being such a big corporation, you might have maybe more leeway in trying out far out ideas than, for example, at a startup where their survival pretty much depends on the positive outcome of that idea. Is that a fair statement, or do you see you're very much tied to the risk of each venture?
I would actually say more the latter. So again, that's something that I had assumed when I started in Siemens, but the reality is with the influence of shareholders and quarterly reports and annual stock market reviews, there is actually very high pressure on monetizing every function that you have in the business. So doing research on topics further out, for example, quantum computing, I think in the current setup is very difficult to do, because probably it's something interesting in the next 5 or 10 years, but no one would be the one saying, okay, I'm willing to spend a few million on this because it may be cool. The pressure usually is more to deliver something in the next quarter or in the next year. And that's why, yes, there is a lot of opportunity, but rather with a shorter time horizon and much closer to the market than further out in the future.
How does it typically work? So you probably start with an idea or a problem, and what are then the next steps? So how does this turn into a product at the very end?
It's different cycles. I would say the first cycles are very similar how you work as a university. So for some reason you have an idea, it's perhaps your hobby, it's something you did before, it's something you think is cool. Um, However this works, and then you build it and you show it to someone. Perhaps you also write a paper. In our case, you would also write a patent before you write the paper, and then you go around and build a story around it. So you try to get away from the IKEA use case and try to find something like, what is a relevant business in Siemens? Who do you know? Who could you talk to? Can you tell the story to the person? Can you hook the person in? Does this person have budget to try it out? Is there a product roadmap where they wanted to do something in this direction anyway? So you're looking for some convergence. So you have to find a fit. And if this works, then you would ask for some budget from the business unit, so to get them in, and then you would build a pilot, which you present to different stakeholders. You would try to find a customer who is willing to experiment, not to have a product-ready solution. You would get feedback from the customer. You would do some market study and would say, well, this one customer thinks it's cool. Our market study says there is a few hundred more customers. So this multiplies into a market of this and that volume. And then you would get the buy-in, and then you would do it and you would build the product. Now, how long this takes actually is very hard to predict. So I would say creating a complete new product line is rather unrealistic. So what would happen there is there would be more a business decision to buy a startup, and then perhaps you would build around the startup. Usually what happens, it's much more incremental, that there is already something there. There is a product. We want to improve the manuals and the instructions for the product, and then we improve this little piece there. Creating a completely new product is a very high risk, and that's, I think, in the Siemens or probably other corporations as well, you would rather invest into a startup that already has done some learnings in the last 2 or 3 years and already has gotten some evaluation from the outside.
Where the fundamental question of can we build this in-house, or should we wait until someone builds this and then acquire their company? So if you now had, the question or the answer to a big question, or the idea for the next big thing, would you then say it's better to do a prototype and do kind of like a proof of market, a proof of concept evaluation in the shape of a startup, and then hope that you get acquired? Or would you approach actually kind of like an in-house innovation circle that pushes you towards the realization of that idea?
Interesting question. So I think it depends on like who you ask. So for me, now being in the research department of Siemens, I would say, well, we have so many brilliant minds here. We have so many labs. We have so many resources. This is really something we should do in-house. We should set up a project and do it. Realistically, I think from a management perspective, someone who would provide me the budget would probably rather say, let's invest into someone from outside who has credibility, who already has investors that are credibility to that. And I think this is what's happening more. And then once you bought the startup, you would engage your research teams and would better integrate it into current product lines. So I think realistically, the big leaps, I think, are happening in the startups, which are then seeking for getting acquired and then leveraging on the mechanisms, on the brands, on the customer base, on the processes, on the liability, on the trust. Someone like Siemens, who has this in the market and has the access. So that's how I see it.
If you look at these idea builds, getting a patent, so the, I don't know, the more traditional approach to maybe improve or build products within the company, how like what would be the percentage of things that you get a patent and then you get a product in the end out of it? So I would guess the idea phase, so we all have like unlimited amounts of ideas. So I think giving a percentage for that doesn't make sense, but you probably have a lot of patents, but how many of them turn into actual physical things in the end?
Yeah, that's also an interesting question, because basically getting a patent is only depending on the willingness to spend money. So what's your budget for doing patents? If you have that, you can do that. And also I see in the current business environment, there's much more reluctance. For example, I can only file a patent if I have a business unit who is willing to sponsor that. So that means many ideas we have and are further out, we probably don't find someone in the moment to file a patent. So we don't put a patent on this, which means for the ones where we have a sponsor, we have the buy-in, the likelihood of getting this into a product is actually very high. But I think we could file many more patents because there's things we believe as a researcher may be useful in the next 3 or 5 years. But probably I wouldn't be able to put a patent on that. You asking me for percentages, it's hard to say. Let's say something like 50 or 60%. So rather high, because we only patent what's relevant, because a patent is including all the fees, can be like 10 to 20K, depending on the number of countries you file it there. So that's why, from a company perspective, you have to be careful. It's not like a paper that you say, let's just put a patent on everything because it may be cool. So there's quite some vetting, and you need a sponsor, which limits the number of patents that we actually file.
So that sounds not too bad. I heard from other people working in industry that they work on these projects for years, and then in the end it gets teared down and by surprise. So that's nothing that happened too often then for you.
Yeah, because I would say the focus of research has more and more moved into consulting and also product development. So of course it depends on the angle, on the perspective you have. If you do more basic research, as you do in universities, so if I would do research which I think would be cool to do, like brain interfaces and thinking about how does the future of work actually look like, in the current environment it's unlikely that we do that. So we do something, for example, now in the COVID times, how can we enable a physical distancing? That's much closer, that's much more realistic. And then, of course, also the likelihood of getting a product out of that, it's already a requirement of starting the research on that. So that's why I think it's a tuning that you as a manager of a research department actually can set. So are you going more to the ivory tower? You have all the cool papers, you have the great news, they have the future, but then the productization of that is rather low? Or do you say, well, we only do what's relevant, but then you probably do not have so many papers and it's not so cool, but it will be probably a better payoff what you do. I think that's a choice. And in companies, usually this is going from one direction to the other, because overall, what I've learned so far, corporate research is just damn hard. It is difficult because in a company, everything is a business, and research is also managed as a business. So research in a way is the outlier, I think, but is managed with the same instruments as you would manage another business in the company. And that's why I think I haven't found the holy grail here. It's always going from one side to the other. Ivory tower, near-time focus, ivory tower, and finding a way in this here.
And then on the other end, if you buy startups, as a company? Will all startups turn into a product in the end?
Yes. So absolutely yes. Yeah. So very often you buy a startup just to broaden your portfolio, so to get into a new business. To give an example, Siemens has acquired a startup called Comfy, which came out of UC Berkeley here, which actually started out in building user interfaces for HVAC, so for controlling your room temperature and provide you a much more convenient environment in the office to make your employees happy in the office. And Siemens has a very long standing traditional business in controlling HVACs and basically having everything behind the wall, which is essential, which is necessary, but it's not cool because you don't see it. It's controlling your temperature, it's controlling your HVAC. So it was just an opportunity for Siemens to buy Comfy to suddenly get access to this much more user-driven development, the visibility there to also develop apps and broaden the portfolio in order to better sell the stuff behind the wall.
What is it that you currently do? What are the exciting things that occupy your mind right now, other than that front end you just described?
What's a great opportunity, and that's also the reason why we are here in Berkeley, to of course have cool people in our team, but also have interesting collaborators at our university next door, UC Berkeley, across the street basically. And this allows us to collaborate with faculty, Eric Paulos, for example, here from the Jacobs Institute of Design. And here we collaborated with a student who has developed a lathe that you can use as a manual tool, but the lathe also can teach you how to use it. So the hand wheels where you control the lathe, they would actually click in at certain positions and would help you to do cuts. So you basically could record the movements from a professional user and could overlay this to someone who is learning to operate this machine. And by that, we can embed training into the work procedure. And that's just something very fascinating, which we could also show at the WIST conference, but also helps us then to transport this idea and discuss this idea with our Siemens colleagues and their customers.
How does it translate to then business cases? Will Siemens start selling such devices, or how does it work?
So what Siemens traditionally sells, the bread and butter of Siemens in the industrial space, are controllers, industrial computers. So units that control machines that other people build. And what we are suggesting here is machines. Perhaps we can extend this to build controllers that control machines, but also teach users how to use the machine, so that we basically have a combination of user and machine. The user is usually the one who is more creative, can work more intuitive, is more dexterous, and the machine is the one which is very routine oriented, which is very precise. And if we can combine this with HCI by giving suggestions, by providing tactile feedback, by training users at the workplace, we believe that this is also a new business opportunity for Siemens to put this into the controller that is going into the machines today.
Sounds like this is a vision to be applied to all kinds of devices, right? If you think about IoT devices that come with certain affordances and teach us more about how they be used, but also how they be efficiently used, right? So right now, I think everyone has an idea how to use their fridge, but maybe they're not doing so most effectively, right? So is that paradigm that you just described, is that something we could see as a next step human-computer interaction principle for IoT devices that tell us not only how to use them, but maybe also how to make better use of them?
The umbrella where we see this is basically future of work. So a big topic in industry is what is called digitalization at this moment. How can we educate? How can we upskill people? How can we make sure that manual work also gets upgraded? And with all the AI that is coming up at the moment, there's also a lot of fear that people are getting replaced. And what we are suggesting here is how can we actually combine this? So someone who has learned to use a hammer and has learned to use a mechanical tool, how can we enable this person also to train and use an AI system or to train a robot? So basically to provide another user interface to turn the systems into tools which can not only be operated by someone who can program, but we develop some much more intuitive means of doing that. And ideally, this is in the workplace. You just keep doing on what you do. The system is recognizing that, is giving some suggestions to you, is capturing that, is training someone else based on your knowledge, and continuously captures this knowledge, but also helps me in my workplace to continuously learn and also develop new skills and be ready for the future and more interesting tasks and routines.
What you described sounds a lot like the system, or maybe the Siemens part of the system is managing resources. So you have the tools and the hardware, or maybe the system, and we want to use it as efficiently or effectively as possible. And then we have the humans, and basically, isn't that the same? We also want to manage the humans as a resource. So humans have certain abilities, and maybe their abilities increase if we teach them certain things. So then teaching them is a good investment, but maybe not. So then I wouldn't teach them things and replace them by a machine. Isn't that like that? In the future, there will be systems and they will manage resources, and the humans will just be yet another resource.
I think that is a vision that probably some people share. I hope we actually can propose something else. So I would hope by doing this, we would introduce much more flexibility, so that there is a goal that you have to build this or you have to do this, but how you do it, this is something you can decide as the worker at this location, and not every micro step is given to you. And I think that's what we have today, that we have very defined routines, and basically where it's too expensive to build a robot to do it, you have someone who is bowing down and getting it, and is this ugly word of a flashbot. And that's, I think, a very dystopian view, and I hope that we can make the workplace more interesting and more creative than just following orders and executing tasks. But in the end, it's of course always a decision about how you use technology. But I hope we can have a positive contribution here.
So in the future, Niels, the sum of your devices will be smarter than the entire Niels, and that's a good thing for you as well.
Maybe the collection of my devices will be smarter than me, right? So maybe not an individual device, but all of them together will probably be smarter than I am. But then together with me, we might be even smarter.
Yeah, Niels in the loop systems.
Yeah.
Yeah, I think an interesting question is to think about what is it what the human can do well, and what is it what the machine can do well. And if you look into today's factories, I think we have a lot of jobs which machines probably could do better. And we could think about how to redesign the workplace to make it also more attractive for the people working there, by giving them more autonomy, by giving them more flexibility, and make it more interesting. And I think that's something we should work for, and should think about how to do this.
Are there things in the long run where humans will be better than machines?
Oh yeah, absolutely. So I think everything that's new, where you have no data, the AI system has like nothing to build upon. So making decisions on incomplete information, where you need intuition, where you need a gut feeling, like what we discussed before. Should I invest into this startup? Should we try this? This is something the machine cannot do. I think in the end, it's a combination. If you are digging a hole, of course, you're using a shovel because it's faster for you to dig the hole, or you use a digger, or you have a robot for that. But if you're thinking about why you're digging the hole, what you're actually creating, what's the purpose of that, then there is no machine that can do this in the end, because there is no world knowledge, there is no bigger purpose. And that's where I see the human superiority, and where I would hope that we could free resources and could focus more on these creative parts than actually on this routine work that's being done.
So probably the decisions get more abstract, right? So, I mean, deciding that the way how I swing my hammer to hit the nail, that can also be considered a decision, but then it's a very simple decision. And then where should I put the nail would be then a more abstract one or more complex one. And then I could say, do I want to actually put a picture on the wall? That would be then yet another level of doing it. And so that's probably the future, that we go from these very simple decisions which are very basic, that have very little impact on the world, to more complex things where we have more impact and change the world.
Yes, yeah. So making work more flexible, making it more attractive, having more interesting job profiles instead of just sticking stuff together that's coming on a conveyor belt, having a bigger full picture of what I'm doing. I think these are interesting directions to go into. And I think it does not make sense to preserve workplaces that can be executed by a machine, because we will always lose this battle, because if it's about costs, you would always automate that. So, but what else can we do? What can we build on top of that? And what other directions can we go? I think that's the interesting part here.
I guess for me, some of this route work that you described, right, this repetitive work, is also sometimes a almost meditative break, right? Because it's different from research or from writing or from reading. And it can be actually quite fulfilling as well to have something that you just like work through. And so if that gets eliminated and everyone is asked to be creative all the time, is that a, I don't know, desirable future in that sense? And can everyone be that creative all the time? I guess these are more philosophical questions. If you want a more concrete question is, does Siemens support a universal basic income?
I think it has been reported in the media that our CEO has made the statement that he would support the unconditional basic income. I think later on he denied that he ever made this statement. So I don't know in the end what he said. I'm a little bit divided on this topic. So because what I would like to avoid, that we just pay off people, that we just write off people. We say, well, there's just a certain amount of people who cannot be creative. We don't need them. So we just pay them. We just pay them to be there. So I think that's one perspective to see it. That's just out of bad conscience. You just pay people and you don't care about them anymore. On the other hand, I also can see and say, well, it gives you more flexibility. You can do much more stuff. I think Spain is introducing the unconditional basic income now in COVID times. Probably interesting to see how that actually plays out in reality. I don't think there is a statement from Siemens about this here. I just can say what I'm thinking about it. What I think is having attractive jobs for everyone. I think that should be the goal, where you find fulfillment and where you like to work. And I agree with you, a routine job can be fulfilling. I just see the danger that this job, since we are living in a capital-driven world, will not stay for long, because if there's an opportunity to automate it, to get it cheaper, then this will happen. So that's why I think it's wise for the one who is in this job to educate herself or himself and find something else just to be employed also in the future.
And so I guess what kind of advice would you give, the students of Niels or mine to dig their heels in and explore in terms of subjects, in terms of skills that they should acquire if they want to be driving some of this or want to be navigating some of this quite ambiguous and uncertain future?
Yeah, so first of all, I would give the advice, follow your passion. So do something that you really like, that you thrive for, that you're convinced of, something that really makes you happy and gives you satisfaction. Don't do anything that may be a major trend or something. Do what you like, and then specialize in one specific topic, whether it's something in computer science or material science or mechanical engineering, and go really deep into that. And in addition to this deepness, to have some breadth. What I think we are missing out a lot is underestimating the mechanical, the physical world. So what you become actually is bringing together computer science and everyday objects, and think about how you can bring computing into an environment, into things, and what kind of consequences this has on the user interface, on the integration, on the power management. So make your hands dirty, do some woodworking, build stuff, build a tree house, do things like that, to be also anchored in the real world and see where the pitfalls in practice are.
And would you go for a startup or for a company? So what should students do if they finish university and then go to Siemens, or go to something that is then later bought by Siemens?
First of all, everyone should come to Siemens in Berkeley. That's of course my advice here, which is, I think, a good blend between the two things that you are describing. So working in an innovative environment like a startup, but then also being in a big corporation. I think in the end, it depends a little bit on your risk profile. Obviously, the startup is a bet on the future. So most startups will fail. So that's just something you should keep in mind. It's cool, but it's unlikely for that to be forever. Even if it's successful, it will be acquired and it will be very different than the startup started for. And the Silicon Valley mindset is more, this is not forever, but at least you qualify yourself in these 2 or 3 years of the startup to jump on the next big thing. And I think this can be very exciting. The corporation gives you much more stability. So it may be much more political, you may be caught by some processes, but on the other hand, it's much more stable. And that, I think, depends a little bit on the risk profile. And then in the big corporation, of course, it also depends on the pocket where you go. So are you going to the business unit where you work with the customers? Are you in a research division? Are you in the acquisition division? So there's a lot of variety, and I think the beauty of a big corporation is you can take many paths throughout your career and directions where you want to go.
So speaking of where we're going to go, I guess the big question now really is, we had the PC, we had the smartphone, we have TikTok now. What's the next big thing? What can you tell us from your industry lens that in 5, 10, maybe 15 years will be something that no one can ignore anymore?
I think we have been waiting for the next big thing. I think we had been all expecting that the next big thing would be augmented reality. So we had been waiting so badly for devices that are beyond a HoloLens, that are beyond something, and it hasn't happened yet. And it really caught me with surprise. I remember it was 2015, 16, 17, 18, 19, 20, every year was the year of augmented reality, and it didn't happen. And we know all the use cases. We would do it if we would have a device. I honestly don't know why it's not happening. So I believe it's still in the space of something wearable. It's something beyond the phone. I think we had been stuck with the phone for too long, enabling us to have a better integration of information and real world activity. What the device looks like, I don't know. It hasn't been the glass, it hasn't been the watch so far. I don't know. I just hope we get a platform soon.
Well, Niels thinks the phone is so perfect that there's no replacement for it.
Yeah, 20 years from now, it will be the iPhone 20 that we will all use.
So you've described our podcast häufig as fest und flauschig for HCI, which so I guess between Niels and you, thank you for bringing in your expertise into this conversation. I really appreciated your point on specializing and digging in your heels in a specific subject and really kind of like building that skill set and confidence. And I think if I were a student, I would probably also try to become really, really good at one thing, and then because not only does that build that confidence, right, but also we find our passions along the way. I think oftentimes I think it's the follow your passion is more of a post hoc statement, because as we become better at something, we might actually discover or actually really enjoy doing that, because also I'm quite proficient at something, right? Otherwise I would just go off and surf all day if I just follow my passion without.
And I would also add, it's not an either or. So I see more and more seasoned managers in Siemens that after 20 years, they leave and join a startup because they have fun, they have the opportunity, this happens. And vice versa, of course, also, like the guys from Comfy, they're now part of Siemens, and perhaps they see this as an opportunity. Or you go back to academia, and of course, there's certain likelihood for things. There's probably unlikely to move from industry to academia at a certain point. But if you want to do this, do it. So if it doesn't stand in the career book, just prove the book different and do it if that's the thing that you want to do. Because in the end, what I learned, it's all about opportunity, and that may be on a very individual level, very, very different.
All right. On that note, proving our books different or wrong.
Sounds good. Yeah. So many thanks for joining us for this evening, morning, whatever it is in your time zone. Thank you.
Thank you
for having me.